Hello. Oh God, I look terrible. So JW did this tutorial on how to make a disk room clone in GameMaker, and I was like, I can make one for Unity because I think a lot of people use Unity and uh, they will be wondering how to basically make something like that in Unity as well. And this is not going to be a beginner's tutorial, and it's not going to really be an advanced tutorial. It's just a way of doing things quick and dirty. The code I'm gonna write is horrible code, it's not really quality code, but it's a way of doing things, like I said, quick and dirty. If you want to learn Unity, I would recommend using either the Brecky's tutorials or Sebastian Lake's tutorials or Tom Francis's tutorials. I'll link them in the description down below. So yeah, let's get to it. Okay, so to start with, you're gonna need Unity and you're gonna need ASC Sprite or ASprite or some other drawing program. Photoshop will do. I just use ASprite because it's convenient. So as you can see, I laid out my Unity folder structure like this. I have resources, scenes, and scripts. In resources, there's animations, audio, prefabs, and sprites, and they are all empty. Scenes just has the scene I'm working with, and scripts is empty as well. So we're just gonna make a player animation. So let's draw something. Yeah, sure. Give it a nice flesh tone and maybe a bit redder. Yeah, that looks good, I guess. So I'm gonna make it have some kind of idle pose. Sure. I'm basically just gonna squash it a bit. So I'm gonna save this as player idle, and I am going to export this as a sprite sheet. You should be able to see it in your folder now. So I'm gonna grab this and copy it to a new document, and I'm gonna make my walk animation now. So let's move it up a bit and a bit more, and let's squash this guy a little bit here. Yep. And let's try to make something that looks, well, halfway decent, maybe? So let's erase the legs. Okay. Sure, why not? Player walk. And let's export that as a sprite sheet as well. So now that we have these two, we need to set it up for pixel art in Unity, which means that we have to set the filter mode to point, we have to set the pixels per unit to the size, and we need to set the compression to none. Then both of these guys also have to be of sprite mode multiple because they're animations, and we're gonna now slice them. So this guy is gonna have 2. This guy is gonna have 4. And now we can drag them in. So let's save this in our animation folder and player idle and player walk. So now that we have these two things, as you can see in our animations, we have 2 controllers. We don't really need that, so we're just going to delete one of these guys. And we're going to rename this to player. I'm gonna so we have this player idle 0 as our controller, so I'm just gonna delete the other one. And I'm gonna rename this to player. So if you open up the animator window, you can see that it just has one state right now. So you can add the other one in, and we can add a boolean to it. Let's call it walking. And let's make a transition from idle to walk and from walk to idle. And the condition is if it's walking, it goes to player walk. If it's not walking, it goes to player idle. One thing you have to keep in mind is that the exit time has to be none and the transition duration also has to be none. You need to do this for all of your transitions in Unity if you want to have a quick, snappy animation change. Okay, so now let's write some scripts for this. So let's create a script, C# script, and let's call it player. Let's open it up in Visual Studio. So let's delete these, and let's have a public animator. And let's say we get the input. So float h is equals to input.getAxis raw horizontal, and float v is equal to input.getAxis raw vertical. So if h not equals 0 and or v not equals to 0, then anim dot set bool walking true. Otherwise, set it to false. So if I am pressing up or down or left or right, then I'm walking, otherwise I'm not walking. Also, I need to get the animator from the current game object, and we don't even make that public actually. So let's just apply that onto the player. And let's try pressing up, down, left, right, up, down, left, right. Okay, so we got it walking. So let's actually make it move now. So rigid body 2D, set the gravity scale to 0, and let's also give it a box collider. Let's make that slightly smaller and something like that. Maybe 0.5, 6, 7. Yeah, something like that looks like it's okay. In addition to this, we need some walls. So we're just going to go into resources, sprites, create sprite, and we are just going to drag that in, and this is going to be our wall. So I'm going to rename this to wall, and I'm going to add a box collider to this. And I'm just going to duplicate that. Yeah, this is okay for now. So I'm also going to change the color of the camera to something like or something like this, maybe. And the walls can be white for now. So let's actually get the player moving. If h is not equal to 0 or v is not equal to 0, then let's get the rigid body, which is going to be called RB. RB is going to get component rigid body 2D, and RB dot velocity is equals to new vector 2 hv, and I'm also going to give it a speed. So let's call this speed about 4, and let's make it public so that we can actually modify it. So times speed. Okay, so let's try it. There we go, we got it moving and we got it colliding with the wall as well. We might want to make that collider a little bit bigger, maybe 0.8. And let's make the offset a bit lower, something like that. Looks good. And let's just make this a bit smaller as well, 0.7. That seems fine. Okay, now that we got the player in, let's make some saw blades. So let's make another sprite. I know JW has his own way for drawing saw blades, but I'm lazy, so I'm just gonna do this. So let's see. I enabled vertical and horizontal symmetry, and that allowed me to draw a really quick saw blade. Although this could use a bit more girth. Yeah, that's fine. It's not perfect, but nothing in life ever is. Okay, sawblade.png. So we're gonna set this up to be pixel art again. So we're gonna set this to point, and we're doing no compression. So let's drag this guy in. Okay, that looks good. Let's also give it a circle collider. Set this to 0.4. We're gonna have a rigid body as well. Set it to 0 gravity. We are going to give it a tag of Sublet. And we're also gonna give it a layer of Sublet. We'll see why we're doing this later. So let's make a script for that called Sublet. Lots of sublets. So we can rigid body 2D RB. RB is equals to get component rigid body 2D. So we have that. And let's make it so that the RB dot velocity is equals to new vector 2 random dot range minus 1f 1f random dot range minus 1f 1f normalized times speed, which we're gonna just define here, public float speed is equal to 4. We're gonna just set it at 4 for now. So this basically gives it a randomized direction. Let's place that onto the sublet, and let's also give the mass of like 1000, so that when it hits the player, it won't be really affected. Also, let's make a physics material and let's make it bouncy. So we need to create a folder called physics materials. We make physics material 2D called bouncy. We set the friction to 0, bounciness to 1, and we can just drag that into here. In addition, we need to make the player actually react to all this. So, oh, I just realized something, like this should be out here. Because if I'm not pressing anything, it should give a vector of 2 of 0, 0. Okay, so now that we have that, let's see if we can make it die on colliding with the sublet. Destroy this. So basically, if it touches anything, there's a tag of sublet, then after that it will just get destroyed. So let's create this as a prefab, and let's just see if we got any problems. Okay, that looks fine, and that looks good. Okay, so next up, we'll make something that actually spawns these sublets. But firstly, there's a bit of a problem. If we actually have a few sublets here, right, for example, and we actually played this, they will actually bounce off each other, which we don't really want because it results in this kind of movement. So let's actually go to our project settings, fix 2D, and make it so that sublets don't touch sublets. And that should do it. So if we actually play it now, and if I can survive for long enough to show it, okay, there we go. It doesn't collide with each other. So we need a controller to actually create those sublets as well. So we're gonna create a C# script called let's see, sublet manager, I guess. And we're gonna make it so that it spawns sublets every few seconds. So let's delete these guys. So we kind of need firstly reference to the sublet prefab, and we also need a time. So public float spawn time is equals to, let's say 1 second. So no, not 1 second, let's say 2 seconds. So actually we want to test it first, so let's say 1 second. So float last spawn time is equals to nothing. And if time since level load is more than last spawn time plus spawn time, then last spawn time is equal to time since level load. So this is just a way to create a timer that like does it every spawn time seconds. So that's every 1 second. So it's going to instantiate the sublet prefab at my position and with no rotation. speaking of which, speaking of rotation, we forgot to kind of add rotation to the saw blade. So let's do that. Let's give it a rotation of 100 degrees per second. Why not? Okay, so let's create an empty, put it at 0, 0, 0, and let's call it saw blade manager. And saw blade manager will basically create the saw blades every 1 second. But of course, we have to actually drag the saw blade in, and we can tweak this from here as well. It's looking good. Okay. Okay, what I think we can do is we can actually make the saw blades slightly larger, maybe. Let's see whether that works out. A lot of mixels up in here, but that's okay. This is just a demonstration. Okay. So now that we have this going on, actually, I can't stand that, so let's actually make a 64 by 64. And let's draw another saw blade. Let's do it like that. Basically, there were like mixed pixels on that, so it's kind of, I mean, it doesn't really matter, but it's a bit infuriating to me. So I'm just gonna save this as that, and we are going to check whether this is okay. Radius should be, let's say 0.8, something like that should be good. Apply this. Okay, so now that we have the saw blades, we can actually move on to making the controller a bit more fancy. So what we're gonna do is we're gonna use this, we should rename this to saw blade manager. Let's set the spawn time to something like 3, and we should have another one called initial spawn time is equals to, I don't know, something like 0.5. Sure. So we are gonna set so we're gonna like remove this from here, and we're gonna set this to public float. Let's see, after initial spawn time, sure, whatever. We are gonna basically set the spawn time to initial spawn time at start. And we're gonna have an integer of how many saw blades we're gonna make at the start. So initials saw blades 4. The reason we're doing this is because we want to fill up the screen as fast as possible. So every time we create one initial saw blades, minus minus, and if initial saw blades is less than or equals 0, then spawn time is equals to after initial spawn time. Let's see whether that works. So it should create 4 in rapid succession. Then after that, it should take longer to actually create them. 1, 2, 3, then another one. Okay, that's good. That's what we want. So now that we have this, let's also make the saw blades a bit more fancy as well. Let's see, what can we do? So I remember in JW's video, he actually made it so that the saw blades are transparent at first and don't damage you. And I think that's a good idea, so let's do that. So bool dangerous, I guess. This goes to false at first. So we get component sprite renderer dot color, it's got new color 111 0.5. So basically setting the alpha to 0.5 at the start, and invoke set dangerous after a second. Normally you'd want to use coroutines for this instead of just invoking, but it doesn't really matter in something as simple as this. So we can set this to true, and when we're checking for the player and we're seeing if it's dangerous, we can say collecting the game object, get component sublet dangerous, then destroy self. So, oh whoops, I've forgotten to do one more thing. So, actually, we can actually just do this. So we can actually set the velocity after that, and we can also set it so that at the start the collider is trigger, and of course when it's dangerous it sets it to false. So you can actually pass through them at the start. So it should work like this, and there you go. That works. The other thing is that when the saw blades actually hit a wall, it should have a bit of random offset in order to keep things a bit interesting. So let's do that as well. We got the prefabs here. So what we're gonna do is we're gonna set the walls to wall layer. Oops, I'm gonna select them all again. And actually, no, let's not do that. Let's remove that. Let's set this back to default. Let's set this to wall in terms of the tag. Okay, so we are going to, in the saw blades, check if it's colliding with a wall, and then add force with a random direction yet again. Except this time it's just it's just going to be, well, we can actually modify how much of this is going to be, but we need to times this by rb.mass, otherwise it's not going to matter much because the mass is like 10,000 or something, and we needed to have some sort of impact. We might need to change this a bit later on, but let's see for now. The thing is, we need it to still be at the same velocity, so let's do this as well. So rb.velocity is equal to rb.velocity. Wait, fixed up it. rb.velocity is equal to rb.velocity.normalize times speed. Okay, let's see if that works. Okay, so as you can see, they will have a slight random offset whenever they hit a wall. So that's good. Next up is UI, score specifically. So let's actually set these guys to black first. Okay, wait, I didn't select this guy. Okay, let's see. Let's create a canvas. And let's create some text. Yeah, sure, import the TMP. Well, okay, that took faster than expected. That's good. So I'm gonna set this to screen space camera, and I'm gonna set this camera, and I'm gonna set the text all the way up here. I'm going to set the starting layer to a new one called UI, and there we go. So now that we have this text here, we can call this something like score text, and score should be here. Oops. Okay, so let's actually try to resize that a bit. Oh, whoops. Something like that. Now we need a reference from this to that. So let's create a game manager as well. Let's create one in scripts. And let's have a reference to, well, firstly we need to include TM Pro, public text mesh pro UGUI, score text, So score text is equals to score, which we're gonna define later. Wait, no, actually, should be something like score plus score. Oops. Damn you, auto completion. Okay, so we have the score here. So score is gonna start at 0, and as you play, score plus equal time the delta time. So I'm just gonna set this to an int. Well, actually no. Let's metaf.round to int. There we go. And let's create an empty. Call it game manager, and apply the game manager. Put in score text, and we have our score. We should also probably pivot this to the top left so that it will always be in the proper place. And we should probably make this scale the screen size so that it will adjust for different resolutions. For example, if you want to turn this into a phone game or something. In addition to that, let's see. We need a restart button as well. So if input.get e down ecode.r application.load_level application.loaded_level. So let's try that now. Okay, there we go. Oh, we should probably not make the saw blades rotate if they haven't snapped out of the dangerous mode yet. So let's see, if dangerous, then rotate. That should work. That looks better. Or actually, how about this? Let's make it 200. Otherwise, rotate at 100. So let's make it like rotate very fast if it's dangerous and not so fast if it's not. So, okay. Time to delta time. 180 might be better. Yep, that looks a bit better. And we of course need to check whether the player still exists. So actually we're just gonna place him down here, and we're gonna have a reference to him in the game manager. Public game object, player object. If player object, then this, else score text is this, score text.text also is you died sure, yeah. Oh, whoa, that's not what I wanted. Oh, it's because I didn't apply the player object in. Okay, there you go. Then if I press R, it restarts, and we have ourselves a game. Let's see how long it can last. This is kind of hard. Okay, let's see. What else do we need? Let's actually add a dynamic camera as well. So create scripts. Dynamic camera, I guess. So what we're gonna do is we're gonna have a reference to a follow object, which is going to be our player probably. and we are going to say transform.position is equals to new vector 2, new vector 3, follow object dot transform dot position. Actually, no, let's do this. Vector 3 follow position is equals to follow object dot transform dot position, and we are going to lerp from 0 to that position because 0 is the center of the screen approximately. So we're going to do something like transform dot position is equals to or follow pose times equals to 0.2, and transform position is equals to follow pose. And we also need to have the follow pose z equals to minus 10 because we need to have it be, we need to have the camera, since it's orthographic, be away from the scene. And let's just add that in. Let's try that now. There we go, we got a dynamic camera. We can also, if you want, if you're more inclined to, we could actually make it lerp a bit. But before that, let's actually cheat and make these guys super large. So we could do something like vector 3.lerp transform.position to this time.delta time times 3. And then it will smoothly follow the player around, but not so much that it goes off the screen. There we go. Oh, whoops, there's an error. Let's see. Oh yeah. If there is such a follow object, then it should do this. Otherwise, it should just stay at that position. Let's just try die real quickly. Okay, good. So nice. So another thing that JW had was the special saw blade, which was larger and stuck to the wall. So we're just gonna make a quick one here. Sure. Make it a bit more blue because it's special. So wall saw blade.png. We're gonna set it up as per normal. So you've seen all this before. So we're gonna set that to be above the walls. We're also gonna give it a circle collider. We're gonna give it 1.8 maybe, 1.5? 1.5 sounds good. A rigid body. 1000, let's set the gravity scale to 0 as well. And let's create a script for it. So I'm going to create a script called wall saw blade. And we basically want it to be moving through the corners from here to here to here to here. So that's a bit more complex to do in Unity rather than GameMaker, but I think we'll manage. So let's have a public list of transforms called corners. And let's also have the, actually we don't need that to be public. We do need a public float speed. Let's just set it for now. And we have to have a current corner, says that's 0 for now. So vector 2 destination is equals to corners current corner, and actually dot position. And let's see, rb dot velocity is equals to destination minus transform dot position. Dot normalized times speed. And if actually, let's do something like this. Vector 2 this to destination is equal to this, and if this to destination is let's say less than 0.5, then we can safely say that it is close enough to the destination that the current corner can be added to if current corner is more than corners dot count minus 1 and current corner is equal to 0. So basically, if it exceeds the list, then after that, just start back at the start. Let's start making some transforms to aid in this process. So that is 0, 0. One here, one here, one here, and one here. And we'll just call these corner. And let's see, wall saw blade. We are going to lock the inspector and set that to have all our corners. Let's just see. Okay, I don't know if this is gonna work. We'll set that to its trigger so that it can pass through. But let's see. We have a null reference exception. This to destination dot normalize orbital velocity. Oh, we did not assign the rigid body. Whoops. Okay, let's try that again. Okay, yeah, that's looking good. The thing is, it can't damage us right now because I have not set this stuff up properly. So is trigger, and then the player also is not is trigger. So it's still gonna be an on trigger enter code in the player. So if it's a solid, we know that it's going to be a wall sublet because that's the only one that's on trigger. So it's a bit hacky, but actually it's very hacky, but it's fine for now. Let's just make sure that the wall sublet is in the exact same position as the first corner, and we can do that by parenting it and then taking it out of there. So let's see. Let's try to get killed by the wall sublet if we don't get killed by the other sublets first. Okay, there you go. It works. And of course, we need it to rotate. So let's do wall sublet transform dot rotate 0, 0, 180 times time dot delta time. Sure, something like that. Nice. Okay. So now let's actually make some particle systems, then we can call it a day. Doing this tutorial stuff is harder than I thought it would be. Also, I didn't make a particle system, I made a particle force field, which I have no idea what that is, but sounds cool. Okay, so let's make some sparks for one. So let's actually create a new folder called materials, I guess. And let's create a new material and let's call this sparks. And let's see, let's have an additive kind of thing going on. Let's do this. You can't see this, but okay, square. And we can just plop that onto the particle system. Oh, whoops. We can plop that onto the particle system. Okay, I'm just gonna grab the renderer and just assign it from there. Okay, there we go. So we can also do some collision. So world 2D, and we can also make the duration something like 0.1. Don't make it loop. Make it emit 1000. Okay. Let's have the shape be a sphere. And let's have the lifetime be something like 1. And let's also make it size over lifetime. Let's reverse that. Something like that. Looking better. Let's set the color to something like this or that. Yep, Oh, whoops. Let's make it a bit more orangey. Okay. And let's also make the lifetime a bit more random. 0.5 to 1. Start rotation, random between constants. 360. So you'll have a random rotation. And let's make it also change color over lifetime. Okay, there we go. Let's down that alpha. And we could probably have less of that. 100 should be good. And maybe start size should be smaller. Let's say 0.2 to 0.5. Yeah, that looks good. Although I would say the start lifetime should be a bit smaller as well. And there should be a bit more of the sparks. Okay, let's just try this for now. So let's call this sparks and let's put that as a prefab. Let's also take the saw blades and put it as a prefab. So in the saw blade, every time it hits a wall, we want to instantiate that. So public game object, spark object, well, spark prefab, and we want it to instantiate spark prefab at transformer position, quaternion dot identity, and we want it to destroy after, I don't know, 3 seconds or so that it won't just stay there forever. Okay, so let's just actually apply that onto the saw blade prefab. So it's gonna have a spark, and let's see whether that works. Okay, yeah, that looks like it works. One more thing is that the sparks do not need to have collision with the saw blades, I believe. I mean, they can. I mean, it might look better, but let's just try it out. Yep, something like that will be good. We can also make it so that this wall saw blade, we can just put a spark onto here, and then we can unpack this completely, and we can kind of set the position to right in the center, and we can make it loop. So it will have a nice sparky effect whenever it's like kind of moving. We can also like have it kind of like offset if you want. Um, Personally, I don't think it's needed. But you can also set like it to a cone or something. So I'm just gonna basically set the radius higher so it. Hmm. Let me see if I can use a donut or something. Let's see, does it look good? Oh, it looks kind of weird to me. Oh, that's interesting. Uh, oh, I didn't set this to solid. Okay. And oh yeah, we need to also set the renderer to something like let's see, where is the sorting order? Ah, there it is. So I just set it to 1 so that it will be above the walls. That looks kind of cool. I think we kind of like came across that by accident. But if we set it to wall, it should look even better. Ah, there we go. Maybe we can actually. So I'm just gonna mess with this apart a little bit. Let's see if we can actually make it random and that'll be better. Not by much. Loop. That looks pretty cool. Actually, I think I'm just gonna stick with let's see, sphere, then restart, then random, and then we're gonna take the wall sublet and we're gonna put it at who in the layer. Yep, this looks okay, I guess. One more thing we could do is we could set a lifetime to something like 1, and we could set the speed to like 1 as well, or a random amount, and that will basically make it so that it will kind of like leave a trail behind. So I'm gonna set this to 2, and actually speed should be 0. Okay, maybe a little bit of speed is fine. Okay, I'm gonna stop tweaking this for now, because I think I just spent a lot of time tweaking it. I tend to get lost in the details a lot. It's a bad trait of mine. There we go. Let's also make all of the other star blades slightly above in terms of like the rendering order, so that we won't have a problem with like seeing them. Actually, that and wall saw blade should be like above everything else. Okay, there we go. So now that we have this, we can add a little bit of sound. I don't really have any sounds on me, so I'm gonna use this software called LabChirp. This is what it looks like. I'm gonna use the randomizer and I am going to play a sound. Probably for dying, I guess. Actually, that sounds pretty good. I thought I was gonna have to do a few more, but that sounds okay. So I'm gonna save that into what was this called again? This room gem tutorial. Assets, resources, audio, player def.wav. So what I'm gonna do is I'm going to set this up so that the player has an audio source. This is not normally how I do these things. I usually have a framework for audio, but from scratch it's basically like this. I'm not gonna play on awake, and I'm going to make it so that the player, when it dies, it will actually oh wait, yeah, so audio source dot, actually let's place it on a different object, like remove this, create empty, audio source, audio, dump it there. Yeah, again, this is not really how I normally will do it, but this is a quick and dirty way of doing it. So audio object. So what I'm gonna do is I'm gonna take the audio object dot transform dot parent equals to null, and then destroy the audio object after 3 seconds. But the audio object dot get component audio source dot play. Okay, let's try this. Okay, audio object. Let's try dying. Oh, whoops. Did I not? Oh, I didn't disable it. Okay, let's try that again. Okay, that's good. In addition, you can actually modify the pitch a bit. So var audio source go this, and then audio source dot oops, pitch go random dot range 0.9f, 1.1f, and this is a quick and easy way of kind of having a lot of different kinds of sounds without having to actually generate those sounds. You see how those sound a bit different? Okay, so next up would be, I guess, I was thinking of having the saw blade bouncing across the wall sounds, but that might be a bit too distracting. We can try it. But I think before that, let's actually make some blood particles. So JW didn't do blood particles for his tutorial, but I am going to. Yeah, so let's do that. Actually, we can just duplicate it off the sparks. So blood, and we can unpack this completely. We can take the blood and we can shove it into here. In terms of the color and material, we need to change this to something like blood, and we need to change that to a sprite material. We take this, take the renderer, assign blood to it, and we can restart that, and we got something that was kind of like blood. So we can actually modify how much speed it's gonna have first. So 1 to 5, and we're gonna have it be a slightly longer lifetime. Actually, let's make the start speed 1 to 10. That's good. Okay, so we're gonna set this to a prefab here, and we are going to have a dev prefab for dev particles prefab for the player. That's what we're gonna put here. Dev particles prefab, and destroy instantiate dev particles prefab. Transform the position quaternion dot identity. Same deal as the sparks. We just need to assign this into here, and we should have a nice little dev particle. We can also make the dev particle actually collide with the saw blade this time, since it's the player's blood. Actually, let's pump that up quite a bit. Yeah, why not? Let's see. Let's see how this looks. That's overkill. I love it. Okay, so let's try that. Okay. Wait, what? Weird. It didn't appear that time. It's appearing every other time now. Oh well. I think it's fine. Whatever. Oh, I know why. It's because this is only on trigger with the saw blade. So I should have created something called void def, and on def I basically do all this, and that's what I get for hard coding stuff. I think that's it, right? Yeah, that should be it. Oh, and one more thing. I think the saw blades we can probably down the... Yeah, we can make it look a little bit more reddish so that it has a bit of differentiation from the sparks. That looks pretty good. See how long I can survive. Okay, not bad. One more thing that I think that you might want inside your prototype and was not covered by JW was maybe a high score, like an actual saved high score. So let's look into that. So we have like a score here and we have it going up. So if score is more than, let's say, player prefs dot get float score score, then oops. Actually no, let's put it to int score int equals to this. We can say if score int is more than get int score, player prefs dot set int score to score int. There you go. So you died high. We can say you died. Press R to restart, and we can also say what the high score is in both cases. So high score is no, actually no, let's not do that. Actually, let's high score int high score is equals to player prefs dot get int score, and by default is 0. So yeah, this should be good to go. So you should now save like all indications of our score in the player prefs. 2, 3, 4. So we got a high score of 4 now. So let's try getting a higher score than 4. And we restart and we got a high score of 8. There we go. One more thing is maybe the canvas score. You can basically put an underlay, and because you if you notice, like there might be some kind of like it's quite hard to read because of the contrast. So I'm gonna put an underlay where it's kind of like has some kind of black offset. Let's offset that split to the X. And there we go. You have yourself a legit ass game. Maybe the score text should be a bit smaller in terms of size, but that's really about it. Oh, and let's stretch that a bit. Yeah, if I have a teacher at school who, well, I graduated already, but if he saw this UI, he'll vomit all over the place. That's okay though, I graduated already, so yeah, that gives me carte blanche to violate every form of design. Okay, and that's about it. Thanks for watching. I'll probably have the link to the project in the description if you want to check it out. And join the Disc Room Game Jam. I think it's going to be quite fun. I might not be able to do it myself, but I would encourage everyone who can to try to attempt it. Bye. Hello, it's Brendan from the future to tell you that I fucked up. Basically, if I go across the things that are translucent, I will still die. So basically what I'm gonna do is I'm gonna have another tag called wall saw blade, and I am gonna check against either wall saw blade. Actually, that's all I'm gonna do. Yeah, that should actually just do it. Let's actually see if that works. So, okay, nothing. And yeah, there we go. So you just make that one edit and you'll be fine. Sorry about that.